We're moving on to the last lesson in Unit 4. We're looking at inverse relations. Okay, so this, it's kind of a transformation, but we'll see. Anyways, let's look at this one more question here. It says, consider the function y equals f of x. What is the equation of the function after a horizontal compression by a factor of 2/3? So we got a horizontal compression by a factor of 2/3, and we have a vertical compression by a factor of 2/5. We have a reflection in the x-axis. If it's a reflection in the x-axis, that means the y values goes from positive to negative or from negative to positive, which means a has to be negative. A is negative, right, because we're changing the y values, so it has to be a, not b. And a vertical translation of 3 units up. Okay, so that means we can figure out the value of a, b, c, and d here. Okay, well, it's a vertical compression by 2/5 and a reflection in the x-axis. That means a has to be negative 2/5, right? It's going to be 2/5, that's the factor, but it's reflected. The value of b, so the factor is 2/3, therefore the value of b is simply going to be 1 divided by 2/3, which is going to be 3/2. Okay, so 1 divided by factor gives you the value of b right there. We have vertical translation. We don't have any horizontal translation, so c is simply 0 because we're not moving anywhere. D, we are moving 3 units up, therefore d is going to be 3. So now, again, if we compare this with a times f of b, bracket x minus c plus d here, we can then fill in the numbers, a being negative 2/5, b is 3/2. Again, x minus 0, so really we don't need a minus 0 there, we can just write x plus 3 for the value of d right there. So there is your answer for the warm-up question. So that's basically the summary of what we did so far, okay, from 4.1 to 4.4. Today, we're looking at reflection. We're looking at inverse, and inverse is actually part of a reflection, but it's not reflecting over x-axis or y-axis. It's actually reflecting in a line y equals x. Okay, if you reflect the graph over the line y equals x, it produces the graph of the inverse relation, and the domain of the inverse relation is the range of the original relation. Because makes sense, right? Because if you flip over y equal to x line, that really means x becomes y and y becomes x. Okay, so I kind of gonna just tell you what happened here. So this is the original function. This, you can see x becomes, we move x outside, right? So you can see x becomes kind of the new y, and the original y value became the x value right there. So these are inverse of each other, and x comma y basically becomes y comma x. You just switch x and y's. When the inverse is also a function, we use the notation f inverse of x. Okay, that's a negative one right there, f inverse of x. We call it, again, I just said it, this is f inverse of x. Okay, so again, it is f, and it's just like inverse sine, right? Inverse cosine, inverse tangent. This is f inverse of x. Okay. Now, here's the think question. Let's take a look. Where would the invariance be if the graph were to be reflected in the line y equals x? Well, if you recall, if we reflect over the line, the x-axis, then all the x-intercepts will remain the same, right? So they are invariant point. If we reflect over the line the y-axis, so x equal to 0, then any y-intercept will actually be the invariant point. So same thing here. If we reflect over the line y equals x, then all the points that were on the line y equals x will be invariant, because it's like you're reflecting over a mirror, but it is on the mirror, so there's nothing for you to reflect on, right? So that's why it's not going to change. Invariant. Okay. All right. So let's look at this example again. This looks rather familiar, I think. We are gonna sketch the inverse of this graph, and we're gonna state the domain and range as well. Okay, so let's write down the points here first. That's -4, -1. B is -3, 1. C is at -1, 2, and D is at 1, 1. And the domain here actually goes from -4 to +1, and the range actually goes from -1 to +2. Okay, so that's the original graph. Now let's do the inverse. So again, inverse simply means we switch the x and y's. So now a prime is going to be -1, -4. Right? You see, I just switched the x and y coordinates. B prime is going to be 1, -3. C prime is going to be 2, -1. D prime actually remains the same at 1, 1, because that is on the line of y equals x. Let's plot the graph, or let's draw the graph first before we state the domain range. Let's see, -1 and -4 is right here. 1, -3 is here. I'm going to join them right away so I don't get confused. 2, -1 is here. And then 1, 1 is right here. So there is our inverse graph. Okay, the domain in this case goes from -1 to +2. The range goes from -4 to +1. And look, these two, they just swap each other, right? You can see that goes from -4 to 1. Now our range goes from -4 to 1. The range goes from -2 to -1 to +2. Now our domain goes from -1 to +2. Okay, so I guess the last question here is this inverse a function? The answer, hopefully you know, I hope you know, but the answer is no. Okay, and the reason why is because this fails the vertical line test. And just quickly recall, that is, if you draw a vertical line anywhere on the graph, and if any of the vertical lines goes through 2 points on your graph, then it's not a function. And really, that has to go back to the definition of function, right? One input gives you one output. This same x value actually gives you 2 different y values, and therefore this is not a function. Okay, so not a function. Okay, that's the example. Here's the practice question. Give it a try. Good luck. All right, so hopefully this is what you got. Okay, so again, you label the points and then just switch x and y to get your new points. You can see, then you can find the domain range, but obviously, again, they just swap. So you really can do it without looking at the new graph, the image graph. And this is not a function, again, because this fails the vertical line test. It goes through 2 points right there. All right, so let's go on to the next example here. It says determine a function or an equation of the inverse of y equals x squared minus 1. We want to sketch the graph of y equals to x squared minus 1 and its inverse. Is the inverse a function? Okay, so first of all, I'm going to draw this first. Okay, so might as well do that. X squared minus 1. Hopefully you know what that looks like. That means we have a vertex at -1. Okay, remember this is just a graph of y equal to x squared, but move 1 units down. Okay, so you should have 2 points right here and 2 points right here. Not that one, this one right here, here, and here. This is x squared minus 1. If you don't remember how to graph this, that's okay. You can always use table values. Okay, so -2, -1, 0, 1, and 2. You should get 3, 1, 0, -1, 0, and 3. Okay, so that's y equals x squared. Okay, now I am going to draw the inverse function first before I actually come up with the equation, okay? Because I think that's easier. So the inverse, so really it's just going to be, okay, I'm just going to, the inverse, recall we just switch x and y. So really the equation is x equals y squared. So we are going to just swap them. So it's going to be 3, -2, 0, negative 1, negative 1, 0, 0, 1, 3, and 2. So 3, negative 2 is right here. 0, 1, 0, and 0, negative 1, negative 1 and 0, 0, 1, 3 and 2. So here is our graph. Okay, here's our inverse graph. Okay, now you might ask, well, isn't that just the equation right there? Yes, but usually we still want to solve for y. Okay, so in that case, we actually almost finished. To solve for y, we simply square root both sides. So you get plus minus root x equals y. So this is key. Don't forget, whenever you square the y squared, the answer on the other side has to be plus minus, right? Because it could be positive root x squared or really negative root x squared, because both will give you the result of simply just x. Okay. And there you go. And if you think about this, this makes sense because this is actually two different functions. One is over here on the top portion of the root x, and this is the negative root x portion of the graph. Okay, so is this a function? This is not a function. This is actually, in fact, two different functions. So this is not, the inverse is not a function. Okay, the inverse is not a function. Okay, again, there's a practice for you to do. Good luck. Okay, so again, there's my y equals negative x squared plus 3. It's a parabola opening downwards, but also move up by 3. You can see, move up by 3 and flipped over x-axis. So there's my parabola. I made a table of values there, and there's my corresponding inverse table values. So it's, again, I just switch x and y's, and then to solve for the equation, again, you switch x and y first. So y becomes x, and then the x here became y, and then you need to solve for y. So moving 3 over to the left, so x minus 3, we still have the negative y squared. Get rid of the negative sign, so x minus 3 becomes negative x plus 3. And then we just have x squared here now. Now you square root both sides, and hence you have plus minus square root of negative x plus 3. Okay, you can see clearly the inverse is also not a function because it fails the vertical line test. So these are not going to be functions for parabola when you draw the inverse. So then here's the question, how can we restrict the domain? Okay, how do we restrict the domain of this parabola so that its inverse is going to be a function? Okay, so this is actually not that bad. Okay, so if you look at this parabola right here, we have a vertex right here at 1, 3. You can tell from here, right? Here's my P, here's my Q. So that's my vertex right there. Now, if we do a reflection over the y equal to x line, we are going to end up with a graph that is not a function. So really what we can do is we can pick either the left side or the right side, and then we can have a function. Okay, so we just split the domain in that way. Okay, so right now the domain is all real numbers. As long as we split the domain, so for example, if let's say I can restrict the domain this way, I can say, let me say x is less than equal to 1. Okay, that means we're only graphing this portion. Okay, we're going to graph that portion. Then that will be a function once we draw the inverse. Okay, so now the question is, what is the equation in that case? Okay, so now we are going to again find the equation. Here is the parabola, original parabola function that we have. Now we're going to switch x and y. So I have x equals y minus 1 squared plus 3. I'm going to minus 3 here. Got y minus 1 squared. I can now square root both sides. This equals to y minus 1. And finally, we have 1 plus minus square root of x minus 3 equals to y. Now notice there's two parts, right? 1 plus and 1 minus. The question is, well then how do I know which part this is going to be? That's a fair question, right? Okay, so now what you need to think about is this. How did we restrict the domain here? We say that x has to be less than equal to 1. Well, recall, because it's inverse, therefore the domain actually becomes the range. So if we have x is less than equal to 1. That means the range for this portion of the graph has to be y is less than equal to 1. So the range for our inverse has to be y is less than equal to 1. Okay, so now if we graph the inverse here, okay, let's actually pick some points and then we can graph the inverse. We have this point right here. This is negative 1 comma 7. So the inverse of that is going to be 7 comma negative 1. That is right here. Okay, and we have right here, this is 0 comma 4. Therefore it's going to be 4 comma 0. This is 1 comma 3. So the inverse is going to be 3 comma 1. And this is 2 comma 4. So it's going to be 4 comma 2. 4 comma 2 right here. And then finally this is 3 7. Therefore it's going to be 7 3. Okay, so you can see if we connect them, it's not going to be a function. But because we restrict the domain to be x is less than equal to 1, so our inverse is actually this portion. Okay, not the top part, because we said that y has to be equal to less than equal to, y has to be less than equal to 1. So it has to be this portion, because the range here is less than equal to 1. Okay, now the other question then is, well then there are two equations here. Which one how do I know which one is the right one, right? Is it going to be 1 plus square root of x minus 3, or is it going to be y equals to 1 minus the square root of x minus 3? Well, the answer in this case, okay, hopefully you can maybe guess, it's going to be this one right here. And the reason being because it says the range has to be less than equal to 1. So, I mean, you can't add to 1 and saying that it's still going to be less than equal to 1. That's not possible, right? Because when we take the square root of some number, this number is always greater than 1. Or sorry, it's always greater than 0 or equal to 0. And if you have some positive or 0 numbers add to 1, it's going to be even more than 1. But we just said that y has to be less than equal to 1. So we have to subtract, because 1 minus something has to be less than 1. Unless it's 0, but which is okay, because we say that y can be 1. Okay, so our equation in this case is that one right there. Okay, so you could probably guess then. The other way, the second way that we can restrict the domain then would be if we restrict it this way, if x is greater than or equal to 1. In that case, range would have to be greater than or equal to 1. And this would be the equation that we just had, which is 1 plus the square root of x minus 3. And the points would just be these three right here. So you know what, I'll just draw it on top right here. So that would be this portion. Okay, that would be that portion. Okay, hopefully that makes sense to you. But what you need to do first is to get the equation. Then you can see there are actually two equations, and each equation represents, you know, either the top half or the bottom half. And you just need to think about, you know, it depends on the domain, right? If the domain is less than or equal to 1, that means the inverse, the range would be less than or equal to 1, and that would be the bottom half. And because of the bottom half, so we have to use the minus, the subtraction one. Okay? Hopefully that was okay for you. We are going to move on to the next example. We are now going to find the inverse, the equation of the inverse. Or, okay, similarly, here it says determine algebraically whether the function is, or in each pair are inverse of each other. So I will show you the first one, and you can think about the second one, and I'll show you the last one, because the last one is quite difficult. You can try it on your own, of course, but anyway, I'll show you the first one. So we want to see if this is the inverse of that. So, well, I guess all we need to do is to try to find the inverse of that. Okay, so we go x is equal to 3y minus 6. And see if once we solve for y, see if it becomes that. Okay, so this is the inverse of the original function because we switch x and y. And now we want to solve for y. So I add 6 to both sides. And now I divide it by 3 on both sides. Okay, so this is the inverse of my original function, y equals 3x minus 6. It is not the same. You can see that says x minus 6, but that says x plus 6. So they are not inverse of each other. They are not. Okay, so I'll let you try the second one. So I'll give you, well, you should pause the video. Okay, so let's see. So we have x equals negative y squared plus 3. X minus 3 should equal to negative y squared. I can divide by negative 1, so I get negative x plus 3 is equal to y squared. And now I can square root both sides, so I get, now notice negative x plus 3 is the same thing as 3 minus x. Okay, so here's the problem. I have two possibilities. It only shows me one. How do I know if this is the right one? Okay, that depends on this. Okay, that depends on that. Okay, so here is the original function. Okay, and it tells us the domain is greater than or equal to 0, which means the range of the inverse has to be greater than or equal to 0. So the range has to be greater than or equal to 0. Okay, because it tells us the domain is bigger than 0. Okay, so domain becomes range, right? So now, if we look at our equation right here at the end, which one should we choose? Should we choose the positive one or the negative one? Well, if we want the range to be greater than or equal to 0, then we have to choose the positive one. So we have to use this. You know, I'm not going to erase it. I'll cross it out. We have to choose the positive one because the range has to be greater than or equal to 0, which is exactly what we have over there. So yes, they are inverse of each other. They are. That looks like a theta. Inverse of each other. All right, last one. Like I said, this one could be difficult. You can try it first. Okay, so good luck. All right, hopefully you should have the very first step. Okay, is switch x and y. Okay, because that's what inverse is. All right, now we are solving for y. Now the problem here is we have two y's. So we need to somehow make it only one of them. And to do that, what we need to do is to factor one of the y, or we need to factor out the y. But we can't factor out the y right now because, I mean, there's a minus 1 right there. So what we can do though is I can first multiply both sides by 3y minus 1. So we get rid of the denominator right there. And then I am going to expand this. So I have 3xy minus x is equal to 2y. Now what I'm going to do is I'm going to move all the y's to one side. So I'll move the 2y to the left, and I'll move this non-y term to the right. Okay, so moving all the y's together, and then all the non-y terms to the other side. So now I have two terms on the left, and both terms have a y in it. That means I can factor the y. So then I end up with 3x minus 2 equals x. And now I only have one single y. I can solve for y by dividing both sides by 3x minus 2. And there is my inverse. And you can see they are the same. So yes, they are inverse of each other. Okay, so that is it for this lesson. And this is actually it for this unit. Hopefully this was not too difficult for you. Let me know if you need some help. Otherwise, good luck with your practice questions.